All right, now we have ourselves regular old indefinite integrals. No, you don't have to worry about stuff like this anymore. These problems are a whole lot friendlier. We just have to add a little extra to it. Okay, so when you look at the integral of 4x to the third, you're thinking, all right, well, let's rip that 4 out and then focus on x to the third dx. Okay, 4 is still there. You are going to say 1 over the exponent, which is 3 plus 1, x to the 3 plus 1. Now, what makes indefinite integrals different is I don't have limits of integration. So at the very end of every single indefinite integral problem, we have to add an arbitrary constant. We don't know what that constant is. We just know it's there because if we were to then take the derivative of this guy, the constant becomes 0. So you become 4 times 1/4 x to the fourth plus c. You guys cancel out to get me x to the fourth plus c, which gives me a. Don't forget that plus c. Very easy to do. Evaluate the indefinite integral of 5e to the x dx. Well, this isn't an indefinite integral, which means I don't have to worry about limits of integration. I don't have to worry about stuff like that. That's dead to me, at least for this section it is. I'll rip out that 5, and I'll just integrate e to the x dx. Well, this is nice. The integral of e to the x dx is just e to the x. However, when I'm taking the indefinite integral, I have to add some arbitrary c. Why? Well, if I were to take the derivative of this to try to go backwards into that c would become nothing. So I need that c there. So in this case, my answer is going to be a. Evaluate the indefinite integral of 3x squared minus 2x. If I wanted to be fancy, I just rip these two apart, like I'm doing right now. And so I will, because I said I would. And as you do more of these, you'll find out maybe this step is not so much necessary. If I want to, I can rip out a 3, so I'm left with that. I can rip out a 2, so I'm left with that. And as I do more of these, you'll realize that that part is also unnecessary. Now we integrate using our power rule. 3 just lives there. Okay, you're going to be 1 over 2 plus 1, x to the 2 plus 1, right? Minus 2. And you're going to be 1 over 1 plus 1, x to the invisible 1 plus 1. Now, when you do the indefinite integral, you have to remember to add an arbitrary c at the very end. Okay, since we're not doing the f of b minus f of a thing, we have to do this. Now we simplify 3 times a third, x to the third, minus 2 times a half, x squared. Beautiful things happen. You cancel out, and you're left with x cubed minus x squared plus c. And as you do more of these, you might be able to skip some of these steps, and you'll find out things that are a little bit faster. But right now we're at the very beginning, which is a very good place to start, and we're just making sure we show all of our steps. Plus, it gets me more YouTube money with my more time and stuff. Speaking of which, like and subscribe. Evaluate the indefinite integral. Well, let's rip out a 6, because why not? And that leaves me with the integral of sine x dx. The integral of sine x dx is going to be negative cosine x. And you know what? Since this is an indefinite integral, we can't forget that little plus c that's hanging out at the end. Let's combine these, put these guys together, make it a little bit prettier looking. And once I do that, I am left with b, and thus and therefore b is my answer. Evaluate the integral of 1 over 2x dx. Well, let's rip out a half. Let's rip out a half, shall we? So the half of the integral of 1 over x dx. Oh, the integral of 1 over x is ln of x. Now, whenever I take the indefinite integral, I can't forget about my little plus c that's got to be hanging out at the end. But that's it. That's all we can do here. That's going to be my guy. Fun stuff. Evaluate this indefinite integral 3 over secant x dx. Well, I don't like the way that looks. I don't like secant just hanging out there. Let's bring it up there and call it cosine. Like that. While we're at it, let's rip out that 3 because we can. As you do more of these, you'll realize that stuff like that's not necessary. Maybe you can skip that step. But now I have the integral of cosine. Gross, 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 gross. Find the antiderivative of f of x, which is bleh. Well, that's just me finding the indefinite integral. So I'm going to write out 3x to the 8 over 9 plus 5x to the 2 over 7 dx. I'm going to split these up into two separate integrals because why not? So 3x to the 8 over 9 dx plus 5, or well, I'm jumping the gun, 5x to the 2 sevenths. Now while I'm at it, oh, dx, can't forget that. While I'm at it, let's rip out a 3, like that. So I have x to the 8 ninths dx. And let's rip out a 5. X to the 2 sevenths dx. So this is the rule, okay? For this one, leave 3 there, right? Do 1 over your exponent plus 1, so 8 ninths plus 1, and then x to the 8 ninths plus 1. We're going to do the same thing here. Let 5 linger, and maybe I should put this in parentheses because that just looks sloppy. Plus sign. Let 5 linger, like that Cranberry song. And then you're going to put 1 over 2 sevenths plus 1, x to the 2 sevenths plus 1. Now, since this is an indefinite integral, we cannot forget our little plus c at the end. So let's not forget that. 3 is still 3. Okay. 8 ninths plus 1 is 17 ninths. So 1 over 17 ninths, x to the 17 ninths. Plus 5. 2 sevenths plus 1 is 9 sevenths, so 1 over 9 sevenths, x to the 9 sevenths. Did I say that upside down? I did. I wrote it upside down, but I said it correctly. 9 sevenths. Wait a minute. Did I? I don't remember. I don't remember, and I'm not going to go back and edit this anyway, so I don't think people make it these far in my videos. I try. Comment if you do. All right, so that's gross. So reciprocal stuff, 3 times 9 over 17, x to the 17 over 9, plus 5 times reciprocal 7 over 9, x to the 9 over 7, plus c. And let's finish this puppy up by multiplying 3 to 9, 27 over 17, x to the 17 over 9, plus 35 over 9, x to the 9 over 7, plus c. Definitely not the prettiest one out there, but I think I did it right, so I'm sticking with it. The indefinite integral of cosine x minus 3x squared plus 3x. Well, we could rip this out into 3 separate integrals if I want to. So I have the integral of cos x dx minus, why don't I rip out that 3? Integral of x squared plus, oh, I forgot my dx, can't forget that, plus the integral of 3 dx. And we'll do each one step at a time. The integral of cosine is sine. Minus 3. The integral of x squared is going to be 1 over 2 plus 1, which is 3, x to the 2 plus 1, which is 3, plus the integral of a constant has me attach an x, and at the end of all of this we have plus c. Can't forget that. So sine x, you cancel out, minus x cubed plus 3x plus c is going to be my guy, baby. Nifty, nifty, nifty.